today I will discuss like what the challenges we face, how we figure out every problem, and we have we'll just figure out those stuff. So first, start with the basics. Like in the SQL database, like this three is the common one. That is like central part of most of the web applications or Android applications, and backup and restoration is like the crucial part of that. So usually for MariaDB or MySQL, you know this, like this has this MariaDB dump and MySQL dump utilities, where you can just dump all of your tables in just a SQL file. So if you need to restore it back, you can just just run the replay the SQL in your database, and it will just restore your data. But it works, but it has some issues. Like the backup time is going to be like proportional to database size. Like if you have like 18 GB of database, it's somewhere sometimes it can take 40 minutes, sometimes it can take less time, more time. It depends on your like database resource usage. If your database is actively like using, then it will probably take this much time. If you have 100 GB of databases, what it will take? Like it will going to take like at least 1 hour. Then it's the issue. Because every time like your site is updating, we are taking some backup, and then we just go with the site update procedure, and then if anything goes wrong, then we restore it back. So this means this time, this 40 minutes, 100 minutes, whatever it takes, it's the downtime in your site. So here is a small chart in like logical backups. Like if you see, as the database size is growing, the duration is also growing. Like you have 20-30 minutes of downtime for the site update procedure. So the solution to this is just copy the database files, right, from the disk. Then it will not have any issues, right? So first check how database actually store the files. So this is a just a structure of MySQL directory for both MySQL and MariaDB. So if you see here, you have these like random IDs, like database names. This is the actual databases where your data is actually gets stored, and there is some others like MySQL, Parsk, sys. This is for internal usage of database. So first know this storage thing, like whatever you are seeing the files here, this is not handled by MariaDB itself. There are various engines like InnoDB, MySum, Area, NBDB cluster. There are many things that handles this file level and disk level access and everything. So we need to somehow manage to back up and restore this. So this is the main one, like InnoDB. So in case of InnoDB, you will see these files like IBD files. This actually stores your actual data. So if you have some table like user table or something, it will have a single file, single IBD file, which holds all of your data of that specific table. And there is obviously some FRM files which actually hold the table definition for your database table. And there is another one, MySum. In Frappe, we use MySum for some specific like global search or like error log, where mainly we don't need transactions or those kind of stuff. We can use MySum. We don't need to get in InnoDB for that. So it has also this same structure, like FRM file is common for everyone to store this definition, and there is some MOI and this MOID extension files which holds your index and actual data. So let's first check how this like simpler way to this achieve this backup and restoration. Like if you have two database server, for example, you need to stop both the service, and you just need to copy the specific database folder from one database server to another database server. And once you copied the folder back, then you just need to start the service. So that's all. It's a simple procedure, right? So it may be useful for many cases where you have this single database on your server, but that's the issue in case of Frappe Cloud, because in Frappe Cloud you have these big database servers where inside you have like 100, 200 sometimes database running on, like in case of shared server. In case of also dedicated servers, you have multiple databases using. So we cannot just shut down your database server for this physical backup or restoration procedure, right? So this was the real challenge, that we need to do this restoration. More specifically, this partial restoration, like we need to restore just one database, or more specifically, we may need to restore just one table of the database in a live database without stopping it or like restarting it. So for physical backup, I'll just prepare a small demo. I can show. Okay. So I have a so I have a server where MariaDB is running on. So let me just slow. I am continuing with the slides only. The network connection is not great here to proceed with the demo. So the main thing you need to do, like in MariaDB, they have make it simplify for us to do this physical backup. So you need to run this flash tables command, flash tables for export. So what it actually does, in a running database, you have many things is going on. Some data is on disk, some data is like on the fly in the memory, some is in your disk cache. So this flash tables command will like push all of your data from memory buffer or disk cache to your actual disk. And as soon as you run this command in a like running a database connections, then you will see there is some new files are generated also. Like we have already seen this FRM IBD files are there. There is new CFG files. So this actually hold your this InnoDB table space information, which is actually required to restore the data back. So once we did this two steps, it's kind of now time to take the backup. But before that, we need to take one more thing in note. We have the data with us, like these IBD files, MOID files, will backup, obviously. But we don't have this schema information. So we need to dump the schema of the tables in a file. And these files also need to be backed up. So for backing up purpose, in case of Rapid Cloud, we are taking like disk snapshot or volume snapshot. We are using AWS for now. So in AWS, we have EBS Snapshot. If you use self-hosted server, you have GFS and other storage support. There also this disk snapshot feature is already available. So this procedure take just like 2-3 seconds sometimes to take the snapshot. Once you take the snapshot, you can just release the table logs, and yeah, the disk snapshot use your actual physical backup. So physical backup is much more simpler. This complete backup procedure might take 15 to 45 seconds. Most of the time it will be under 1 minute. Sometimes it most of the time it took 15 seconds, but sometimes you cannot do multiple disk snapshot at same time. That time it can just grow, the time can grow, but it will not cross 1 minute. But the main benefit is you are taking the disk snapshot here. So that means if you have a 2 GB of database, that is going to take the same time. If you have 100 GB of database or 200 GB or 300 GB, whatever the size is, this time is not going to vary much. Like most probably if you have too much like 1 TB of database, most probably it will take like 1-2 minutes to flash the tables, but not more than that. Compared to logical backup. So yeah, physical backup is the like happy way, but restoration comes with many hidden things. So let's see the restoration procedure. So to begin with, we need to convert the like snapshot, whatever we disk snapshot take, we need to convert it to a volume first. So in case of FC, we just use AWS APIs and all to create the volume. And once we got the new volume, we attach the volume in the running database server. So you have now two disks attached, like one is the main disk where your live database is currently running, and you have the backup disk where actually your snapshot, disk snapshot, or like you can say the physical backup is there. Okay. So in next step, we need to drop the tables, like whichever table we want to drop. If you want to do partial one, like you need only like restore 2-3 tables, you can drop those tables. And once you did that, we need to recreate the tables. So if you remember, like in physical backup, we have already dumped the table structure already in a SQL file. So that has this information for table creation purpose. So once you create the table back, you need to start discarding. So this is specific to InnoDB engine. So in case of InnoDB engine, they have this support to import the IBD files back. So before importing the like copying the stuff back, we need to discard the table spaces. So once you discard table space, the IBD files like got deleted from the actual database. Then it's time to like copy your files. You can just copy the, you don't need to copy the FRM files. You need to just copy the CFG and IBD files to your like running database. Once you copy those back, you need to run this command again, this import table space. So it tells InnoDB that it's time to import the table space configuration. So it's not like your data is not actually getting imported. If you remember, it has some CFG files. So it configures the database and InnoDB engine that there is new InnoDB like file is there. You need to configure it. It's not doing more than that. So it's a very low overhead procedure. So once you import the string, look, most of the time, that's all. You can just restore your database back. For MySum storage, just simply copying the files is most of the time is enough. But we did this like implementation in 1 month almost, and then we start like testing for testing purpose. We just roll out in FC, and then we started seeing like odd errors that is not mentioned in documentation somewhere. So first problem we face that this slow copy. So we have this snapshot, right? From snapshot we are creating the volume, and from volume we are copying the files from backup to the actual database. So we start seeing that we are not getting, like we are provisioning 500 Mbps of disk, but we are not getting any performance. We are getting 5 Mbps of speed in copy. Then upon finding, we found is some AWS thing. So this is the stat for one restoration, like 9 GB of files take 25 minutes of that, like completely cancel the purpose of like physical restoration or backup procedure. So let's see how the snapshot process actually, like in case of AWS, how they do the snapshot, like from top of the, so once you take the snapshot, what it does, it doesn't keep it to like their local server. So they move it to some cold storage. It can be S3. In some documentation, they have written that they move the snapshot to S3. Okay. So once you start the restoring the data back, you say I need a new volume from this snapshot. So this procedure, like blazingly fast, it just take 4-5 seconds just to create the volume from the snapshot. But there is the hidden issues, like it start doing lazy loading. You got the disk obviously, but your disk is not initialized. Like if you try to read a single block, then it will send the request to the cold storage or S3, wherever they have stored the file, and it will fetch that specific block and populate that block, and then you can read it. So that means there will be high latency, like at least AWS or EBS has single digit latency, but in this case we'll start getting 50-60 milliseconds of latency, and yeah, we'll get and maximum 15 Mbps or something speed. So AWS suggests one thing that we should do. There you have DD utility, also like some other tools to trigger this read. So that does a simple thing, like you have this block completely. It just try to read every block of your disk to make it initialize before you are doing any disk operation like copy or move files. But that didn't work because those do sequential read. So first initial idea was that DD is working in 5 Mbps or 15 Mbps or whatever. Let's run like 5 DD command like in like parallelly, right? Then we can get at least 80, 90 Mbps. But there is another issue that came up, like we started seeing too much IO rate and high CPU usage, and that is not a good sign because it's a running database. We cannot impact other sites for this restoration purpose. So then upon digging dive, we saw that this DD essentially use Linux sync calls. Like sync specifically says that your applications is need to read some disk bytes. It just send the call to kernel and kernel will back with your data. So it's a sync procedure. So your application threads are also blocked there. Also the CPU will constantly check whether the data is available or not. So then we moved these new things that came in Linux 5.11. So they have this concept IO ring. It's kind of async IO. We don't need to, like, the application don't need to wait for the result, and the system also don't need to like check poll every time for the result. The IO ring itself will notify the application that your data is available. What you want to do with this, you can set some callback. I'm not going in deep here. You can, Mattermost has a good blog. If you later want to check, you can check the Mattermost blog on IO ring. So we write a like library for this IO ring. IO ring thing is much newer thing. So by default, like in Python, OpenCall, or maybe most of the languages, there is not currently very good implementation. So we take a Go library and write a write the library there, and then convert it into a Python library, like file warmer. So you can just see in the example is cut, but if you see here, like we need to just pass the files which we want to warm up, and it will use IO ring and some batch processing to like process the small files in a batch. So these procedures like enable us to like reach much higher throughput. Like if you have provisioned the backup volume with 300 Mbps, most probably you are going to touch the 70-80% of like throughput during the warm-up session. Previously it was just 15 Mbps or 1 Mbps. So previously this 10 GB of warm-up procedure was taking like 16 minutes of time. That came down to like 1 minute. So that was a good improvement in this case. Like it's very important for restoration process. Then we suddenly came up with this MySum table corruptions. So if you see, like for InnoDB, you see that they have this discard table space, import table space, various commands are there. But for MySum, we are just copying the files. All right. So that creates the problem. Also, MySum table is prone to like corruption, but very easy to recover as well. Like, so after the restoration procedure, one day I was just checking. I was just randomly checking which check table that whether every table is healthy or not. Then I suddenly saw that there is something wrong. Like it's saying that size of data file is something like this much bytes, but it should be 0. Then I found that the issue is like we have created the table from the SQL and we have copied the data back. So the MySum index file is and the table structure like table column definitions file is not in sync, and there is a mismatch that it is checking that data file like AMID file is this much, but it's saying it should be 0. Then The simple fix is like you just use this repair table command, and you can just pass a like use FRM flag they have. So that will help to reveal the index very fast. What it does, it just go through your index file. It just find out the data for that, what is the length of your data, and it just set in your internally in table column definition, and that just fix your like table. Yeah, then we found this odd issue, like again this full text index corruption. It was a confusing issue as well. We saw that full text index is not supported in physical backup and restoration because it has its own data structure. So we just think that we will drop it and recreate it, right? We'll drop the full text index and create it back. That should solve the problem. But we just like see these errors, like table is started, like full database server is started crashing. Like for 10 MB of like table, I am creating a full text index and is like crashing the whole database server. So after some like guesswork, we found out that like dropping a like index from your database is not like like syncing back all the configuration. It's just a metadata change. Like somehow internally it just change some flags that this index has been deleted, and some background jobs will later delete the index files. So the option was like drop the index, and then if you call this optimized table. So if you call this optimized table, so it will sync all the data back. In case of your InnoDB table is corrupted, it will still able to repair the InnoDB tables. Also like fix all of your indexes if that is crashed as well. And then we just run again, came back to the same thing, like create the full text index, and it worked. Like somehow it like magically worked, this procedure. And yeah, it's a little bit complex. There is many things that can broken apart and that can like cause issues in backup and restoration process. But the benefit is like here, like previously this was the chart, the logical backup thing, where it took like it just increases like with the database size. Now see some like test result. So here is the result. Like for 1 GB of database also it's going to take the same time. For 20 GB also database, it's going to take the same time, like 15 to 45 second range. So this is the like also physical restoration is a little bit tricky, but it also depends on many factors. But it's not that much slow. It's comparable to the logical restoration thing. Like if you see like for 21 GB of database, it takes 15 minutes. But the main thing is of this restoration procedure, it can take some time for copy paste, but your database is not need to do much thing. So there is low overhead. So for restoration of one big site in your dedicated server, it's not going to impact the other site's database. Yeah. So that is the main benefit from whole backup and restoration procedure.